Hi, today we'll talk about one of the Oracle DB wait events called DB file scattered read wait events. So this wait event occurs when the Oracle database where its database session is waiting for the physical multi-block I/O request to read data from the disk into the buffer cache. Mostly it happens when there is a full table scan going on. The database session has to read the entire table, and it is reading multiple blocks. In case the Oracle has to do a full table scan, and it has to read all the tables, it does a multi-block read. It reads multiple blocks at a time. There is a parameter called db file multi-block read count, which is the default value is platform dependent, but it's mostly in Linux environment you might see like 128. So based on that parameter, there's a maximum uh, blocks it can Oracle can read at a time. Now, why it is called scattered? Because it's actually it reads bunch of blocks, multiple blocks, bunch of blocks uh, from the disk, but it actually reads sequentially in a single large contiguous operation. It reads multiple blocks, but actually when you write to the buffer cache, it just throws out these blocks everywhere. It finds some free buffer in the buffer cache. So the blocks are scattered in the buffer cache. That's why it's called the DB file scattered read. It's actually on the read operation it's doing. It will do a sequential. It will read bunch of blocks from the disk, from the data file, but actually it writes to the memory the database buffer cache in a scattered way, in discontinuous location. And it's a normal to have some level of full table scan, and if you see a little bit of DB file scattered read, it's not a problem because sometimes Oracle does full table scan. And but if you see this wait events dominates your database wait time, and it's you see it's a top one of the top wait events in your AWS report, then it may be a good maybe a good idea to investigate and find out which SQL is going for full table scan, or which session is having this scattered wait events, and then investigate. Now, what are the possible root causes? As I said, mostly when we have a full table scan, and we'll also try to do a. I'll show you a demo at the end of this video, and I'll try to recreate this DB file scattered and see how it happens exactly in a database. So the root cause is one is full table scan. When the database is reading the entire table block by block, so it reads the entire block and put it in the buffer cache. So or it's doing an index fast full scan FFS, because it is reading all the blocks from the index instead of going navigating the index tree. It is reading all the blocks. Mostly happens when you do a range search using between clause or in clause, greater than or less than, things like that. And if you have a poor execution plan, the Oracle optimizer thinks like full scan is better than index due to outdated statistics, stale statistics, or some problem with the application query logic. So it might go for a full table scan, and you will see this DB file scattered read. Or sometimes Oracle is doing a full table scan, but it's not that bad. But there is some bottlenecks in the your disk I/O system. So in that case, also you will see, because the session is waiting for the disk read to complete. So you'll see this wait events, but it could be due to a slow disk I/O system. Now, how to fix it? As I said, it's a full table scan. So why do you see a full table scan? Because first you check the explain plan of the SQL query to see if it is using full table scan. Maybe the index is missing. Um, Index is not added. Index is not there at all, or because of the table and index statistics are not updated, and the Oracle is thinks full table scan is better than a index scan. For example, let's say one table has million of records, and the statistics says it has only 100 records. The Oracle will think it's a small table, I can go for a full table scan. But when it tries to do a full table scan, it has to read the entire table, which is a large table, and that will show as a DB file scattered read uh, for the session. Also, sometimes the index could be corrupted or unusable. You may have to rebuild the indexes. Check the DB file multi-block read count. You want to leave it as default. Do not increase the number. Otherwise, if Oracle can read more multi-blocks at one stretch, it might think like full table scan will be better than index, so it will all try to go for more full table scans. That could be bad for the performance of the database. And another reason could be you need more memory into your SGA or the buffer cache, because the buffer cache is so small that when you're doing we're reading the entire table to the buffer cache, and after some time the buffer cache is flushing out those blocks back to the disk, and so it is reusing it. So next time when you do a full table scan, Oracle try to read it again from the disk, and you see more and more DB files scattered. So look at your SG and buffer cache size also. And if you see in AWS report average IO wait time is high, that could be an indication that your physical IO latency is high, and it could be a problem with your hardware disk IO. So investigate that, and if possible move the data file to a faster storage like SSDs. This one sequel, how to find out if you have a DB files category. You can look in read alert session where state is waiting, or it will waited for a short time, and an event is DB files category. Or you can also search in visualization for the specific SQL or specific username or SID. So there you'll see three columns: P1, P2, P3. P1 is the file number, data file number from which the session is reading from the disk. P2 is the starting block number of the multi-block read, the multi-block read that is doing right now. What is the starting number? And P3 is the number of blocks it is reading. Mostly it will match if it is a big table, so it will match the DB file multi-block read count number. So we'll see that. We'll see a demo, and we'll see how we'll try to recreate a DB files category in our Oracle session. Let's get into the database. So I've logged into two sessions. One is sys. The white screen is I've logged in as a sys, and the black one is I've logged in as HR user. So we'll run one select command from the HR EMP table where EMP ID equal to, we'll put some employee ID number. So let's see. This is a very simple table, but it has a lot of records. It's around kind of 14 million record, I think. So we'll load it. We'll select for one employee ID. So there is no primary key or anything. You'll see multiple records with the same employee ID. Now, before we start anything, we'll run this query. This is I'm running from VDLS session. The SQL query I just showed you. Session selecting the state and seconds in wait and event. So now my HR user is doing now already is doing. I'm selecting from count star, so it's already doing DB file scatter read. So initially when I try to do this, it is does not doing DB file scatter read. It is doing a direct read path. That's a various reason for that. Like Oracle, based on the table statistics, it makes a decision whether to go for a DB file scattered read or direct read path. Direct read path means Oracle will read the blocks from the disk and directly put it on the PGA and send it to the user session. It will not put it in the buffer cache. So little bit of modification I had to do to make to recreate this or simulate this D file scatter read. One is change the uh, DB file multi-block read count. It was 128. So Oracle thinks I can read 128 blocks. That means 128 into 8 KB. That much of data I can read in one shot, one operation. And also based on the statistics, and it was making a decision to go for direct read path. So there are two things, two other hidden parameter that I had to set it on the this one. There is alteration small table threshold. So how Oracle decides what is a small to large table? There's a threshold, and there is a direct read decision statistics driven. So that made it false. So this parameter decides that the Oracle will take a decision whether to go for direct read path based on the statistics driven. So we made it fall. This is just in my local environment to create the DB files category, but do not make these changes in production. It's not required also. So if you make these changes, so you will see this DB files category, and even if you are doing a select star from HREMP where employed equal to something, 103, it will see DB files category, and you can see this as I mentioned, P1 is the file number, data file number. P2 is the start of the block number. And P3 is how many blocks it is reading, because my multi-block read count max is 4. The maximum it can go for 4. So that's why it's reading 4 blocks at a time. So every time you'll see this DB file scattered read, you will see, mostly you will see 4, count 4 here. So again, still is doing same file, data file number. It's reading 4 blocks, DB file scattered read. But difference is the starting block was 111111510, and here it is 127012. That means it skips on reading multiple blocks, like a 4 blocks at a time. So every time you read, if every time you select, get this information. If you are still having DB file scattered read, you will see a different P2. P3 will be mostly before. See, the P3 is 4 DB file scattered read, the P2 is changed now. So yeah, so that's about it. So because this table has no index or no primary key, nothing. So it's just, and it's a large table, and Oracle it's doing a DB files category. So that's about it. Thank you. Bye.